This starter employs the star-delta method for starting the motor, which involves changing the motor's winding connection from a star configuration to a delta configuration once the motor reaches a certain speed. In this tutorial, we will demonstrate the automatic star-delta starting method for 3-phase AC induction motors. This will include providing a schematic, power and control, PLC ladder, and wiring diagrams. We will also explain how the star-delta starter works and discuss its applications, as well as its advantages and disadvantages. Here you can find the PLC program ladder logic for the star-delta starter. Most induction motors start with the DOL direct online starter, but when a very large capacity induction motor is started with a DOL starter, then it may cause a disturbance on the supply lines due to large starting current surges. To limit the starting current, large induction motors are started at a reduced voltage method. Star-delta starter is the popular method to start a large induction motor at a reduced voltage. Star-delta starter means two separate states of starting. First, the motor starts with a star connection, and when it reaches up to 75% to 85% of its full load speed, the motor runs in delta connection. When the motor starts without a star-delta starter, first starting current would be the 4 to 6 times of the full load current. Second, an oversized power capacity cable is required to handle the initial high starting current. A programmable logic controller (PLC) is an industrial computer control system that continuously monitors the state of input devices and makes decisions based upon a custom program to control the state of output devices. This is a starting method that reduces the starting current and starting torque. The device normally consists of 3 contactors, an overload relay and a timer for setting the time in the star position, that means starting position. The motor must be delta connected during a normal run, in order to be able to use the starting method. The received starting current is about 30% of the starting current during direct online start, and the starting torque is reduced to about 25% of the torque available at a direct online start. This starting method only works when the application is light loaded during the start. If the motor is too heavily loaded, there will not be enough torque to accelerate the motor up to speed before switching over to the delta position. When starting up pumps and fans, for example, the load torque is low at the beginning of the start and increases with the square of the speed. When reaching approximate 80 to 85% of the motor rated speed, the load torque is equal to the motor torque and the acceleration ceases. To reach the rated speed, a switch over to delta position is necessary, and this will very often result in high transmission and current peaks. In some cases, the current peak can reach a value that is even bigger than for a dull start. Applications with a load torque higher than 50% of the motor rated torque will not be able to start using the start delta starter. This starter is widely used in industries where high-power motors are required, such as in oil and gas, mining, and manufacturing. The Star Delta starter offers several advantages, including reduced starting current, better control of inrush current, and reduced stress on the motor windings during starting. However, it also has some disadvantages, including increased cost and complexity, longer starting time, and reduced torque during starting. Working principle of Star Delta starter. Star Delta starter is most common and extensively used to start the induction motor. This is the most common reduced voltage starter. To understand the working of, first we have to understand the three-phase connection in Star and Delta configuration. First, let's check the simulation results, what it looks like before loading it to the PLC module. Even if you don't get the module, you can examine its execution, as you can see in PLC Sim. Let's get into PLC wiring. So as to do that, provide 0 volt to PLC input pins, 24 volt to the push buttons. Then connect the PLC inputs to the push buttons' respective address. Then 24 volt power supply to the PLC common output address, then to the main Star and Delta contactors coil tag respectively. At last, their respective indicator lamp needs to be connected to indicate their status, and in addition the stock status is also indicated through its indicator lamp, which is lamp. In Stat Delta, starting an induction motor is connected in through a Star connection throughout the starting period. Then once the motor reaches the required speed, the motor is connected in through a Delta connection. Monitoring and inspection of several processes is becoming dominant part of the automation technique in any industry. So the automation is basically the delegation of human control function to technical equipment for increasing productivity and quality, reducing costs, increasing safety in working condition. Advantages of Star Delta Starter. 1. Low cost. 2 components require very little space to build the starter. 3. Limit the starting current by 1/3 of the Dole starter. 4. Simple design and operation. 5. Comparatively cheaper than other voltage controlling methods. 6. Torque and current performance of the Star Delta starter is well. 7. It draws 2 times starting current of the FLA full load ampere of the connected motor. 8. It reduced the starting current to 1/3, approximately, as compared to DOL direct online starter. Disadvantages of Star Delta Starter. 1. A specific motor is required which has 6 leads. 2. Starting torque is also reduced by 1/3. 3. Supply voltage must be the same as the rated voltage in the Delta connection. 4. Starting torque is also reducing to 1/3 because starter reduces the starting current to 1/3 of the rated current as line voltage also reduced to 57%. 5. It required 6 leads or terminals motor Delta connected. 6. For Delta connection, the supply voltage must be same as the rated motor voltage. 7. At switching time from Star to Delta, if the motor does not reach at least 90% of its rated speed, then the current peak may be equally high as in direct online starter, thus it may cause harmful effects on the contactor's contacts, so it would not be reliable. 8. We may not use Star Delta starter if the required application or load torque is more than 50% of the 3-phase induction motor's rated torque. Starting and controlling of 3-phase motors using automatic Star Delta starter. A Star Delta starter is an electromechanical device used to start and control the speed of a 3-phase induction motor. This starter employs the Star Delta method for starting the motor, which involves changing the motor's winding connection from a Star configuration to a Delta configuration once the motor reaches a certain speed. The Star Delta starter includes a control circuit that typically consists of a timer, contactors, and overload relays. When the motor is started, it is initially connected in a Star configuration to reduce the starting current, which can be up to 6 times the motor's full load current. After the motor reaches a specific speed, the timer switches the winding connection to a Delta configuration to ensure the motor operates efficiently. Characteristics and features of Star Delta starter. The starting current is 33% of full load current for Star Delta starter. The peak starting torque is 33% of full load torque. The peak starting current is 1.3 to 2.6 of full load current. Star Delta starter can be used only for low to high power 3-phase induction motors. It has reduced starting current and torque. The 6 connection cables are needed for motor terminal box. In Star Delta starter, current peak and mechanical load on changeover from Star Delta. Applications of Star Delta starter. As we know, the main purpose of Star Delta starter is to start the 3-phase induction motor in Star connection while run in Delta connection. While keep in mind that Star Delta starter can only be used for low to medium voltage and light starting torque induction motors. In case of direct online DOL start, the receiving current at motor is about 33% while the starting torque reduced about 25 to 30%. This way, Star Delta starter can be only used for light load during starting the motor. Otherwise, the heavy load motor won't start due to low torque, which needs to accelerate the motor to rated speed while converting to the Delta connection. Components used in the star-delta starters, mainly contactor and thermal overload relay, are described as follows. A contactor is an electrical device which is used for switching an electrical circuit on or off. It is considered to be a special type of relay. However, the basic difference between the relay and contactor is that the contactor is used in applications with higher current carrying capacity, whereas the relay is used for lower current applications. Contactors can be field mounted easily and are compact in size. Generally, these electrical devices feature multiple contacts. These contacts are in most cases normally open and provide operating power to the load when the contactor coil is energized. Contactors are most commonly used for controlling electric motors. There are various types of contactors, and each type has its own set of features, capabilities, and applications. Contactors can break current over a wide range of currents, from a few amperes to thousands of amperes, and voltages from 24-volt DC to thousands of volts. In addition, these electrical devices come in varying sizes, from handheld dimensions to sizes measuring a meter or yard on one side approximately. The most common application area of the contactor is high current load. Contactors are known for their capability to handle currents of over 5,000 amperes and high power over 100 kilowatt. Heavy motor currents produce arcs when being interrupted. These arcs can be reduced and controlled using a contactor. Operating principle of a contactor: the current passing through the contactor excites the electromagnet. The excited electromagnet produces a magnetic field, causing the contactor core to move the armature. A normally closed NC contact completes the circuit between the fixed contacts and the moving contacts. This permits the current to pass through these contacts to the load. When current is removed, the coil is de-energized and opens the circuit. The contacts of the contactors are known for their rapid open and close action. A thermal overload relay is a relay designed to protect electrical systems from overheated conditions. It does not shut off power to the circuit but instead senses when the current has reached a high enough level and opens, allowing the motor to continue to run. Thermal overload relays protect motors, transformers, and other electrical devices from overheating. These relays are often installed at points where there is an electric circuit with several devices on it. If one of these devices overheats, it can cause damage to itself or other parts of the circuit. As the start push button is pressed, both main and star contactors' operation indicators are turned on, and as the timer's preset value reaches now, the star contactor instead turned off and the delta contactor turned on, while in both cases the main contactor indicator remains turned on unless the stop push button is pressed. Now let's have a closer look, and the contactors switch from one state to another. our control circuit is operating as our expectation. Now let's passes towards to the implementation on a motor terminal box. In star delta starter, initially, the motor is started in star configuration. The voltage across each phase is reduced by 3 factors. After a period of time motor reaches 75 to 80% of full load speed, then the motor runs in delta configuration. A star delta starter is the most commonly used method for the starting of a 3-phase induction motor. There are mainly 4 states in star delta starter. First, off state. This is the off state of the starter, all the contactors are in the off position. Second, star state. In the state, main and star contactors are closed and delta contactor is open. The motor is connected to star. Third, open state. The state is the transition state from star to delta. The main contactor is closed, only both the star and delta contactors are open. There is a voltage across only one end of the motor windings. The rotor is still rotating. Fourth, delta state. The main and delta contactors are closed and the star contactor is open. The motor is running with full line voltage and full load speed. This is the provider of 3-phase power supply to the power circuit, as it is shown represented by RST, and turn on the supply to deliver for any load. In this case it is an induction motor power circuit that can be done through circuit breaker. Thank you very much, and don't forget to subscribe and share the video if you find it helpful. Stay creative. This is PRD-SS channel.